In this lesson, we are going to go over functions, domain, and range as inequalities. So to talk about functions, I like to think of it in terms of a Venn diagram, where this graphic organizer illustrates how functions are a subset of relations. So every function, because it's inside the relation set, every function is a relation. So let's define what a relation is. It's just a set of ordered pairs. Often it's written in set notation using braces, and there is a comma in between each ordered pair. Your domain is your set of all possible x values, and range is the set of all possible y values. So when you write the domain and the range, again, you write it in set notation. Best practice is to order your values from least to greatest. So the smallest x value is -9. There are two 2's, but I only list it once because I'm just concerned with the value, and 1, 4. So my domain is -9, 2, and 4. Where the range is, again in set notation, -2, 0, and 5. This time -2 is twice, but I only list it once. There are a lot of different ways you're going to see a relation. So one way is just a set of ordered pairs. It could be written as an XY table, a mapping, where this is kind of nice because it's really easy to see the domain and range values. Or a graph is probably the most common in mathematics. The three that you see on your screen are relations, but they are not functions. So let's define a function and then consider why the last three were not functions. So a function is a special type of relation where each x value is paired with exactly one y value, or I could say each element of the domain is paired with exactly one element of the range. So I just told you that this previous one was not a function. So what was the issue? Well, the value -1 is paired with two different y values. So that's a problem. So to create something that would be a function, well, I could kind of use a very similar table, but I'll just either get rid of the problem child or just change the value. I'll say it's 5, 4. So notice that the y value can be there twice, but the x value cannot be paired with two different y values. In the map, this function, because each element of the domain gets exactly one element of the range. So having two arrows going into a y, totally fine. So again, on the last screen, we saw that this one was not a function. This one here is not a function because I have the x value 4 is being paired with two different y's. So often kids will say to me, you know what, look for any repeating x's. If x's are repeating, then it's not going to be a function. Not really the best way to say it, but I get why kids do say it. Graphs are easy. All you need to do is take a vertical line. Anywhere you draw a vertical line, it can only hit the graph at one point. So no matter where I draw it here, it's only going to hit at one point. And again, on the last slide, you saw that this one here was not a function, just a relation, because if I draw a vertical line, it will pass through the graph twice. So let's illustrate with some examples. It says, first of all, let's decide, is this a function? And we need to explain. Well, I say no. There's two issues, okay? So the issue is with -3. It's paired with two different y values, paired with both positive and -3. There's a second issue here. The value -1 is paired with two different y values. So when you're explaining this, just pick one problem with it. So I'm going to say no because -1 is paired with two different y values. Now, what's the domain? Again, from least to greatest, -3, -1, and 0. The range is all your y values, so that's going to be -3, -1, 0, +1, and +3. Try this one on your own. Hit pause and then play when you want to check your answer. So this is a function because each x is paired with exactly one y value. The domain and range are listed as well. Which mapping illustrates a function? Well, this one has an issue right there. 5 is paired with two different y values. On A, each one is paired with exactly one y value. Now again, you can have repeated y's, that's fine, but the x's can only have one arrow coming out of them. So this is mapping A. And now let's look at the graphs. Which value is not in the range? Okay, so the range is the y values. So you're really looking at your y-axis. So is 0 in it? Well, the height of 0 is right here. Well, I see a point right there. That ordered pair would be -8, 0. So that's in the range. That one's fine. How about 3? Here's 3 on the y-axis. And I have an open circle right there at -2, 3. So at a quick glance, it looks like 3 might be there, but because it's an open circle, 3 is missing. Is 4 there? Yep, I got a whole bunch of points right here on this segment. 5 is right here at the ordered pair 2, 5, so that's present. So 3 is the value missing. Now let's look into graphs writing the domain and the range as an inequality. This is typically the most challenging for students of what we've learned here. What I encourage you to do is kind of, if your segment or graph is starting and stopping, to kind of mark the endpoints. So this endpoint here is -1, 3, and over here I have 3, -2. So my domain values. As I move from left to right, all of my x values are between this point and this point here. Well, what is this x value? It's -1, and then they move along here all the way to +3. So what do I say? Say my domain is all x values between or equal to -1 and 3. So x is in the middle, -1 is the smallest, 3 is the greatest. You can read that as -1 is less than or equal to x, which is less than or equal to 3. Now the range, I think how low to how high. So I'll highlight, or I'll mark this in green. So my graph never goes lower than that green dotted line and never higher than this green dotted line. So the lowest it is right here, and then the highest it is right here. What are those y values that measure the height? So the highest is +3, and the lowest first is -2, is less than or equal to y, because we're talking range, which is less than or equal to +3. Okay, final example like this, and then it'll be your turn to practice. So the domain, again, a little trickier. All my x values, so how far left? Well, this graph never goes further left than where I sketched that green line, and it goes forever to the right. This arrow here implies it's going to keep going and going and going and never stop. So the smallest it is right here, and what is that x value? It's -1. That's the ordered pair -1, 1. So it's all values bigger than or equal to -1. Now my range, how low to how high? Well, this is going to get forever lower. It's going to drop and drop and drop. But the highest it gets is up here, this open circle. And what is that as an ordered pair? It's the ordered pair 2, 3. So y is smaller than 3, and I'm not going to say equal to because of the open circle. Y is just less than 3. Okay, this is definitely a concept you need to practice with domain and range, so please proceed to do that. And as always, if you have questions, don't hesitate to reach out for help.